What if I tell you that the age-old dream of an elevator to space might soon become a reality? Well, that's what the recent discoveries of the Apache Point Observatory in New Mexico seem to be pointing at. This state-of-the-art observatory has been diligently scanning the heavens, and the revelations are nothing short of groundbreaking. Imagine a structure so vast it extends from Earth's surface into the cosmos, a whopping 22,236 miles high. Welcome to the concept of space elevators. Think of it, a colossal cosmic lift, an elevator that can take us from the familiar grounds of our home planet up and away into the vast expanse of space. An idea that sounds straight out of a science fiction novel, right? But let's delve into the fascinating reality of this concept. A space elevator would essentially be a gigantic tether anchored to the Earth's surface, with its other end reaching beyond geostationary orbit. Now, the materials required to construct such an audacious feat of engineering would need to be extraordinarily strong yet light. Carbon nanotubes, a material 100 times stronger than steel and 6 times lighter, is a prime candidate. But what about the sheer size of this project? Well, it's nothing short of mind-boggling. The cable alone for this space elevator would weigh an estimated 750,000 metric tons. To put that into perspective, that's around about 150 times the weight of the Empire State Building. Yes, you heard it right, 150 Empire State Buildings. This colossal tether would extend into space, reaching a height of approximately 22,236 miles. That's nearly the same distance as circumnavigating the Earth at the equator. How can such a colossal structure stand, you ask? The answer lies in the enigmatic world of physics. To comprehend the physics of a space elevator, we need to dive into the principle of centripetal force. This is the force that keeps an object moving in a circular path. It acts in a direction towards the center of the circle. Now imagine a long cable extending from the Earth's equator into space. As the Earth spins, the cable too would be carried along, moving in a circular path due to the Earth's rotation. This creates the centripetal force that would keep the elevator upright, counteracting the force of gravity trying to pull it down. Speaking of gravity, its strength decreases as you move away from the Earth. So the further up the elevator you go, the less the force of gravity pulling you down. This means that the cable doesn't need to be equally strong throughout its length. It can be thinner and lighter where the gravity is weaker, helping to make the whole structure feasible. Now let's talk about speed. The top of the space elevator would be traveling at a staggering rate of about 3.1 miles per second. That's roughly 10 times the speed of a bullet. This speed is necessary to balance the gravitational pull of the Earth, ensuring that the elevator stays upright and does not collapse. But don't worry, you wouldn't feel this speed while traveling in the elevator. Just as you don't feel the Earth's rotation, even though it's spinning at about 1,000 miles per hour at the equator, you wouldn't feel the elevator's speed. You'd just enjoy a smooth ride into space. So, you see, building a space elevator is not an act of brute force. It's a delicate dance of physics, a ballet of forces on a cosmic scale. It's about using the Earth's rotation to create the necessary centripetal force. It's about balancing the decreasing force of gravity with the increasing speed of the elevator. So, in essence, the space elevator would be a delicate balance of forces, a ballet of physics on a cosmic scale. Constructing a space elevator is no small feat. It presents a myriad of challenges, both technical and logistical. The first hurdle to leap over, and quite possibly the tallest, is finding a material robust enough to endure the colossal strain such a structure would be under. Imagine a ribbon stretching from Earth's surface, piercing through the atmosphere and extending into the cosmos, tethered to a counterweight at its far end. Now, this isn't your average ribbon. It would need to be made of a substance that combines the strength of steel with the lightness of a feather. Currently, the best candidate is carbon nanotubes, tiny cylinders of carbon atoms that are about 100 times stronger than steel and 1/6 its weight. However, we are yet to figure out how to manufacture these nanotubes on a large scale, and that's just one of the many technical conundrums we need to solve. Next, consider the counterweight at the top of this celestial elevator. It would need to be around 2 million kilograms, or roughly the weight of 300 elephants, to keep the cable taut and the elevator stable. Transporting such a colossal weight into space is a challenge in itself, not to mention the cost implications. Now, let's take a moment to consider the potential dangers of space debris and micrometeorites. With thousands of satellites and countless pieces of space junk orbiting the Earth, the risk of collision is a real concern. And then there are micrometeorites, tiny space rocks traveling at incredible speeds that could easily sever the cable. Despite the seemingly insurmountable challenges, the potential benefits of a space elevator are too significant to ignore. The ability to transport goods and people into space cheaply and efficiently could revolutionize our relationship with the cosmos. So, the question isn't whether we can afford to build a space elevator, but whether we can afford not. Where do we stand in 2024 in the quest to build a space elevator? Well, one of the most interesting things happening right now is the work being done by the International Space Elevator Consortium. This global collaboration of scientists and engineers has been conducting ongoing research and development efforts towards the realization of this celestial elevator. They've been tackling issues such as material strength, climate design, and counterweight placement, all with impressive grit and determination. Now, let's talk about timelines. The construction of a space elevator isn't something that's going to happen overnight. It's a monumental task that requires significant breakthroughs in material science, engineering, and logistics. However, we're not entirely in the dark about when we might see the first space elevator. Current estimates suggest that we might be looking at the first functional space elevator within the next few decades. Yes, you heard it right. Decades, not centuries. This timeline, of course, assumes that we continue to make steady progress in research and development and that we can overcome the many challenges that lie ahead. But let's step back for a moment and consider what this could mean for humanity. A space elevator could revolutionize space travel, making it more accessible and affordable. It could open up new opportunities for scientific research, space tourism, and even the colonization of other planets. The possibilities are truly mind-boggling. However, it's important to remember that we're still in the early stages of this journey. There are still many hurdles to overcome, many questions to answer, but the dream of a space elevator, once the stuff of science fiction, is slowly becoming a scientific possibility. And so we continue, undeterred by the challenges, driven by the tantalizing possibility of reaching the stars in a way we never thought possible. The space elevator remains a tantalizing possibility, a feat of engineering that could revolutionize space travel. To sum up, the concept of a space elevator is as fascinating as it is complex. We've unpacked the mind-boggling facts, delved into the physics, and tackled the challenges that come with building such a monumental structure. We've also explored the current research and future prospects, and it's clear that this is no small feat. The space elevator, a concept once confined to science fiction, is now a subject of serious scientific pursuit. It's a testament to the relentless human spirit, our insatiable curiosity, and our undying ambition to reach for the stars. But it's not without its hurdles. From the sheer engineering challenges to the financial implications, there's a long road ahead. Yet, the potential rewards are immense. Imagine a world where space travel is as common as taking an elevator ride. While we may not be boarding a space elevator anytime soon, the journey to its creation promises to be as thrilling as the ride itself. And if you like this explainer, we believe you would also enjoy the video shown on your screen right now. Click on it and let's catch up there.